Hi everyone, as you know, atoms are the building blocks of the universe, and in the chapter of chemical bonding, we will better understand why these atoms combine together in different ways. This video is the first in the series of chemical bonding, where we will look at noble gases and how ions are actually formed. At the end of this video, you should be able to explain how ions are formed, and explain why noble gases are considered inert or unreactive. For a long time, scientists have wondered about what makes atoms stick together in forming molecules or compounds. If you go back long enough in history, people used to think that there were hooks on atoms that enable them to actually hook onto each other. There's even this hypothesis that says that when atoms come close enough, there will be this region that overlaps, creating a chemical bond. Others have come up with various models suggesting how atoms actually bind together. The model that we study in secondary school is based on this thing called the octet rule, where electrons are either shared or transferred between atoms. As you go forward and learn more advanced levels of chemistry, there are other models that can explain the chemical bonds that forms between atoms, one of which is the valence bond theory and the molecular orbital theory or MO theory. If you're interested, you can always go and read up more. In O-levels, you will encounter three main ways that atoms join together. The first is via ionic bonding, the second is via covalent bonding, and the third is via metallic bonding. Before we understand how and why bonds form, we need to take a look at the structure of noble gases. You can find the noble gases in group 18 of the periodic table, starting from helium, neon, argon, and so on and so forth. The noble gases were not discovered until rather recently, in fact, over just 100 years ago. At that time, the periodic table already had many elements. There were gaps in the periodic table, and scientists then thought that the gaps were to be filled by metals based on the trends and properties. No one knew that there was an additional group of elements that were yet to be discovered. This was when a guy by the name of Cavendish took air from the atmosphere, removed all the known compounds from it, and found that the nitrogen obtained was denser than the nitrogen from chemical compounds. And this must be due to something else that is present in air that is not known to man at that time. And that was actually the starting point for the discovery of argon. And argon was so named as the lazy one because it did not form any bonds with any other elements. If we recall what we learned from atomic structure, we know that the noble gases have a fully filled valence shell of electrons, with helium having 2 valence electrons and all other noble gases having 8 valence electrons. We say that they have a fully filled valence shell, and that is the reason for them being relatively unreactive or inert. Given that they do not form compounds readily with other elements, it was very difficult for scientists to discover them. Given their other properties such as being colorless, odorless, and gaseous in nature, it's no wonder why scientists did not discover them until relatively recently. So we say that noble gases have a stable electronic configuration because they have this thing called a fully filled valence shell. When you have 2 valence electrons in a fully filled valence shell, we call this a duplet electronic configuration. And for 8 valence electrons, we say it's an octet electronic configuration. Noble gases exist as single atoms, we call them monoatomic. We find that elements that have a fully filled valence shell tend to not gain, lose, or share electrons with other elements. And when scientists study what happens when atoms bond together, it is common for them to result in a fully filled valence shell. In this chapter, we will learn that when atoms do not have a fully filled valence shell of electrons, they will either gain, lose, or share electrons. Let's start by looking at the gain and loss of electrons. When atoms gain or lose electrons, they form this thing called an ion. An ion can be formed when an atom or group of atoms gain or lose electrons. So let's see whether you can spot some patterns. Study this diagram and observe what happens when different atoms form ions. Pause the video and think about it. Do you notice any pattern between the first row and the second row? The first question I want to ask you is, how do we know whether an atom will gain or lose electrons? Let's look at the examples on the left. For your metals which have fewer valence electrons, they tend to lose because it's much easier to lose fewer number of electrons than to gain a greater number of electrons. So for lithium, it only needs to lose 1 valence electron to form the lithium ion, and for beryllium, it loses 2. So when you lose 1 electron, you become positive charge of 1, and when you lose 2 valence electrons, you have a positive charge of 2. For the nonmetals on the right, notice they have a larger number of valence electrons, 5, 6, and 7, for example. So they will gain the necessary number of electrons to have a fully filled valence shell. So if I have 5 valence electrons to reach 8, I need 3 more. If I have 6 already, I just need 2 more. If I have 7, I'll just need 1 more. One thing I would like you to notice is how the naming is done. So for your nonmetals, when the atom becomes the ion, the end part of the name will change to the IDE form. So nitrogen becomes nitride, oxygen becomes oxide, and fluorine becomes fluoride. For the metals, the name stays the same, just that we'll just state that it is an ion instead of an atom, just to be clear. In summary, there are 2 kinds of ions. The cations are the positively charged ones on the left. It's very easy to remember because you can think of the letter T as the plus sign. Okay. And the anions are the negatively charged ones, and you can look at the letter N, which stands for negative. Okay, so we have cations being positive and anions being negative. Let's summarize what we have learned so far in your notes. So firstly, we notice that metals tend to lose electrons while non-metals tend to gain electrons. You can remember this very easily using this acronym, Mama Loves Nasi Goreng, which stands for metals lose, non-metals gain. In terms of the number of electrons that will be gained or lost, you look at the number of valence electrons. In terms of the naming and drawing of ions, there are some conventions. Firstly, the name change to the IDE for your anions. We use a square bracket and indicate the charges, and the charge of the ion is written as a superscript. So notice the number comes first, then the sign. So 3 minus, 2 minus, and minus. The 1 is omitted when the charge is just 1. So using lithium as an example, lithium being a metal, and lithium has 1 valence electron, it'll be easier for lithium to just lose 1 electron than to gain 7. Also, when a particle has a very large charge, let's say it's a -7 charge, it will be very unstable. Right now, I'd like you to pause the video and to try these checkpoint questions on your own. So the aluminum atom has 3 valence electrons. It will lose the 3 electrons to have a fully filled valence shell. We form the aluminum ion with a charge of 3+. Since it has 3 more protons than electrons, it has an overall positive charge of +3. We can represent this change using a half equation. What this means is that we show what is original on the left and what is formed on the right. So we have the aluminum atom forming the Al3+ ion, and as a result giving out 3 valence electrons. Since the aluminum ion has 10 electrons, it has the same electronic configuration as the noble gas neon. Let's try the next example for chlorine. Pause the video, give it a try first before we resume. Since chlorine has 7 valence electrons already, it just needs 1 more to have a fully filled valence shell. This means that chlorine will gain an electron to form the chloride ion. So once again, take note of the change in the name when we form the negative ion. Also, we represent the electron gain using a different symbol to show that this electron that was gained came from somewhere else. Since now it has 1 more electron than protons, it has an overall negative charge. In terms of the half equation, we say that the chlorine atom gains 1 electron to form the chloride ion. Since it has 3 electron shells with a total of 18 electrons, it has the same electronic structure as argon. How do you think the sulfur atom will form an ion? Pause the video and give this a try. Since sulfur has 6 valence electrons already, it will need 2 more to have a fully filled valence shell. Therefore, sulfur gains 2 electrons. The resulting ion is called the sulfide ion, IDE again. So the sulfur atom gains 2 electrons to form the sulfide ion. Since it has 2 more electrons than protons, it has a negative charge of -2. Let's move on to some explanation questions. Try to answer this question. Describe and explain how the calcium ion is formed. Answer in terms of the electronic structure. So the calcium ion is formed because the calcium atom has 2 valence electrons, which is then lost. In the process, you get a fully filled valence shell. So we can represent it as calcium, form the calcium ion, and 2 electrons are given out. An isotope of phosphorus has 16 neutrons. The phosphorus atom has 15 protons. We can find that in the periodic table. And since it has 16 neutrons, the mass number or nucleon number will be 31, 15 plus 16. The phosphorus atom has the configuration of 285. Since it already has 5 valence electrons, it just needs 3 more to have a fully filled valence shell. So you will gain 3 electrons. Since electrons are negatively charged, when you gain the 3 electrons, you have 3 minus overall. So remember the name change? So this is called the phosphide ion. The table in your notes show the list of common ions that we encounter in the syllabus. You will notice that some of them consist of ions formed from a single atom, and some of them consist of ions formed from a group of atoms. For example, the ammonium ion here is a polyatomic ion, meaning that there are more than one atoms in that group, and overall that group of atoms share a total charge of +1. Some other polyatomic ions that you may encounter frequently are like the hydroxide, nitrate, sulfate, carbonate ions. So to summarize, when we draw the structure of ions, make sure you have the brackets, you have the charges, and the electrons that are gained, make sure you use a different symbol. The monoatomic ions are quite straightforward. The polyatomic ones, you can see that there are more than one atoms that are joined together, and overall the whole thing shares a charge. The drawing of dot and cross diagrams as you see here will be covered again later in the chapter. So let's do a very quick recap. We talked about noble gases. They have a stable electronic configuration, which means a fully filled valence shell. This means that they are inert and unreactive. We also explained how ions are formed. Cations are positively charged ions, formed when metals lose electrons. Anions are negatively charged ions, formed when your non-metal atoms gain electrons. We also learned how to draw the electronic structure of the ions and how to name the anions especially. So the positive and negatively charged ions do attract each other as opposites attract. That is called ionic bonding, which is what we will cover in the next video. So that's all for today. I'll see you in class.